Hello and welcome back. We're getting into the meat of the project now. This video is going to be a little bit of a different format from our previous assembly instructions in that I'm kind of going to do it from the perspective as if you are trying to implement your own sensor platform instead of building one of our pre-made sensor platforms, just so you get the feel for how to contribute and utilize our project. This is what we're going to be building today. So it has mounts for the EZO probes, an instrumentation amplifier, or instead of the instrumentation amplifier, it can have a BNO055 motion sensor and an SHT31 temperature and humidity probe. My most sincere wish is that since we've done so much legwork for developing the platform, it's a lot easier for you to think about some high-level design decisions with regards to your sensor module. One of the first things you're going to want to do is think about where within the module stack you want your sensor module to live. It's really not too hard a decision. It just depends a lot on your specific mooring in your application. For the EZO sensors, we want the probes to be in the water and the antenna to be out of the water. So we really just want to maintain a clear vertical orientation with the antenna at the top and the heaviest weight at the bottom. So that kind of locks us into, okay, the antenna's at the top, batteries at the bottom, and then because our sensor module has probes that run to the outside of the enclosure, we're going to put this right above the battery. If you're at the point that you're actually ready to deploy, it seems very probable to me that you've already kind of ironed out a lot of the kinks in your circuit, a lot of the kinks in your code, and you're looking to integrate it into the rest of the platform. A really easy way to get started is just to use whatever platform you're developing on. If this is the Raspberry Pi or some derivative, please check out our Git repository. We also are trying to support microcontroller boards within the Feather ecosystem. But the natural next step will be to ensure you have good connectivity from your sensor module to the rest of our ecosystem and a solid mounting procedure. In our case, we actually designed custom carrier boards for these EZO probes so that we have a great mounting system. And I know it's not exactly the thing you want to do, but trust me, it'll be worth it. If you do have special connectivity requirements that we haven't already met within the project, for example, you use something other than I2C and USB to communicate, you'll likely have to adapt the electronics module a little bit. In the generic configuration of the pipe buoy, you'll see that we have very little headroom on the Raspberry Pi. If you require more space, it's actually not hard to create the headroom that you're going to need. Using Onshape, which is online and free, you can generate new modules tailored to your specific application. In this case, we want to recreate the baseline module with a little bit more headroom. And because all the relevant variables are defined ahead of time, it's very easy to drop down this platform and give yourself the space that you need. So let's say you have a new Raspberry Pi shield and you need to have your custom shield in addition to our custom power management board. So now you've added a centimeter of headspace and you're ready to go. All you have to do is download this file and put your own custom mounting footprint onto it. Likewise, for the sensor module itself, you can use this same generator program to make your own module. In our case, we only need about 75 millimeters of length. And we actually do want a symmetrical mount. So in that case, I'm setting the platform offset to 0. And this is actually the exact process I used to generate the module that we're using for the project. Again, you're not limited to our 3-inch ecosystem. Let's say you want to use a Jetson Nano, which would only fit inside a 4-inch tube. All you have to do is change your tube diameter. And now you're off to the races with your brand new buoy ecosystem. The most difficult part of this assembly is actually going to be tapping the threads for the EZO probe mounts. And I know it sounds like a complicated process, but I think given the cost of the probes, you're going to be spending at least $300 if you want these kind of quality probes in your system, that it's well worth spending another $20 to $30 on a proper tap and taking the time to tap it out so you can actually retrieve the probes without relying on any gluing processes. You may have noticed that the probe I'm using in that shot is a 3D printed prop probe because I made the terrible mistake of gluing my stupid probes into PVC couplings. Don't do this. Be better than me. Find a way around it. In this case, the Atlas Scientific probe mount works just fine. We deployed it to 16 meters before, no problems.